Today's presentation is going to be on chapter 5. It's all about, finance. We have simple interest for section 5.1. We have compound interest for section 5.2, future value annuities for section 5.3, and present value annuities for section 5.4. Okay, to start off, simple interest. These are the formulas for simple interest. It's INT, which stands for interest, equals to PV, present value, times R times T. Okay, the interest is the fee paid to use someone else's money. The PV is present value or principal. The R is the interest rate, and the key thing that it has like the percent symbol, and time is going to be in years. Okay, now there's also, once you find the interest, the future value is equal to PV plus INT. But from this formula, FV equals to PV plus INT, we get another formula, which I'm going to substitute the present value times the interest times time for the interest. Then I'm going to factor out the present value. So I'm left with 1 plus the interest times time. So it's either going to be two formulas, this one here on the left, and the one here at the bottom on the right, which is the future value equals to present value, 1 plus R times T. So when you use each formula, it's best to put all the variables and see what you're looking for. For example, the FV stands for the sum of the principal and the interest in the future, right? After so many, after so much time, what's the future value? That's what the FV stands for. Present value, the same as the one on the left, is the present value or principal, interest rate, and time in years. Now, here's what you need to know. If months are given, then time will be given months over 12, because the time is in years. But if it's given in months, you put the given months over 12. And the interest rate must be in a decimal. For example, if you have 5%, you're going to move the decimal 2 places to the left and drop the percent symbol. Like 5% equals to 0.05. So this is what you got to know for simple interest. Okay, now let's do an example here. Example 1. It says Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest at 3.5% for 5 years. Find the total amount that Martha paid to her uncle and how much interest did Martha pay. So here it's either going to be, right, which formula should we use? Is it the interest equals to present value times interest times time? Or is it the FV equals to PV 1 plus R times T? Does it matter? No, it doesn't matter. Okay? For example, here, I'm going to use both formulas so you see that it doesn't matter. So to start off, I'm going to use the interest is equal to present value times the interest rate times time. Okay, and then, so after you find the interest, you're going to find the future value by adding the present value to how much interest Martha had to pay. Okay, so again, I'm going to put the INT, the PV, the R, and the T. So from the word problem, I'm going to extract the information. Okay, it says Martha borrowed $12,000 from her uncle to buy a used car. Her uncle charged simple interest of 3.5% for 5 years. So here, guys, what are we looking for? Find the total amount that Martha paid to her uncle. So we're looking for the future value, correct? How much interest did Martha pay? So we start off with our present value is 12,000. My interest rate is the one with a percent symbol, which is 3.5. And we gotta move it. We gotta drop the symbol and move the decimal point 2 places to the left. Okay. And the time, right, is it's 5 years, so it's going to be 5. So all we do is plug into the formula, right? There's my present value, there's my interest rate, and there's my time, it's 5. So you put in the calculator, and we get $2,100. So then to find the future value, right, then we have to use this formula, right, because the future value is equal to the present value to the interest paid. So the future value equals to the present value, which is 12,000, plus the interest, which is 2,100. So for the first part, it says find the total amount that Martha paid to her uncle. So it's going to be the present value plus the interest, which is 14,100. Okay. So then, how much interest did Martha pay? Right. That was what we found at the beginning. So Martha paid. Total was 14,100. Interest paid was 2,100. So on the next slide, I'm going to use the other formula, which is the future value equals to present value 1 plus R times T. Okay. Again, same problem, but now I'm going to use the other formula. Okay, now to use this formula, right? This is to find the future value. So to find how much interest did Martha pay, we have to subtract. We're going to find the future value minus the present value will give us the interest. How much interest did Martha pay? Okay, but let's do this. Let's find the future value first. So present value is 12,000. The interest rate is 3.5, which is 0.035. The time is 5 years. So plug everything in. Right? There's my present value. There's my interest rate, which is 0.035, and there's my time, which is 5 years. Plug in the calculator, so we get 14,100. So that's the total amount that Martha paid. Okay. Now to find the interest, we're gonna subtract the present value from the future value. This is my future value, which is it's what we just got right now, which is 14,100. The present value is the amount that Martha borrowed, which is 12,000. So 14,100 minus 12,000 will give us 2,100. So total Martha paid is 14,100, and the interest paid is 2,100. At times, you can use either formula, but some other times it's easier to use one or the other. Okay, I believe that's going to be like our next example here. Okay, now. Example 2, Mariana will need to pay a tuition bill of $7,500 for her daughter in 10 months. What dollar amount can she deposit today at 1.25 simple interest to have enough to pay the tuition bill? So we're going to use this formula here, guys, because it gives us this is going to be my future value, right? Mariana will need to pay a tuition bill of, you see, that's in the future in 10 months. So here we have to use the formula because we're looking for the present value. Okay. So in this case, what are we looking for? We're looking for the present value. How much money? This is here. What dollar amount can she deposit today? Right. So we're looking for the present value, which is today. So this is my future value. That's how much Mariana needs in 10 months. The interest rate is 1.25%, right? And again, we convert it to decimal. So we drop the symbol and we move the decimal place 2 places to the left, which will give us 0.0125. The time is in months, right? So it's going to be 10 divided by 12. So all we do is plug into the formula. Okay. The book likes to use this formula. Okay. I mean, that's what the formula uses, but these two formulas are the same ones. Because to solve for present value, we divide both sides by 1 plus RT, right? So it's going to give us future value divided by 1 plus RT. So we plug everything in. So if you do it this way, you have to be real careful in the calculator. So it's always best to leave the numerator how it is, and then do everything for the denominator. You're going to put in the calculator 1 plus 0.0125 times 10 divided by 12, and it's going to give us 1.01041667. Now we divide it, and it's going to give us $7,422.68. Okay, now another way I like to use this way to plug into the calculator, because this way you do not lose the flow of the calculator. It's like a non-stop. Example: Okay, I'm going to plug everything in. So here I'm gonna enter the calculator. I'm going to put everything in parentheses. Right? So it's going to be 1 plus 0.0125 times 10 divided by 12 is going to give us 1.01041667. Now you're going to use the inverse key. The inverse key is like multiplying by the reciprocal. Okay, so you're going to hit this key, right? And it should give you, when you press this key, it's going to give you answer -1, which means it's going to use the inverse of the answer, which is 1.01041667. And then you enter 7,500. Okay, my bad, guys. Let me see here. And then we get 7,500. Okay, we enter that, and then this is the answer that we get: $7,422.68. You see, guys, we get the same thing. But the formula on the bottom, right? It was the same formula from the beginning. The inverse key will help you to to do the step here. Or I mean, like to multiply, or to do the step here. That's what the inverse does. You get 7,500, and you multiply by the inverse of the answer of 1 plus 0.0125 times 10 divided by 12, which was 1.01041667. So the inverse key does this for you guys. And if you use, this on the bottom, by using this method that I'm showing you, you do not lose the flow of the calculator. Because at times students have a hard time putting all the parentheses, because you can plug this into the calculator, but you have to put the correct amount of parentheses. Okay? Simple interest continues. Example 3. John received a $10,000 loan from his aunt to buy a car. His aunt charged him 2.5% interest. How long was the term of the loan if the interest accrued was $125? So here the solution is which formula to use. They give us John received, right? They give us the present value, and they give us the interest, and they give us the interest rate. So we're looking for time. So this is the best formula to use, because we cannot use the other one because they don't give us the future value. But we can get the future value by adding these two, right? But with the given information, without doing nothing else, there's a formula to use. The interest rate equals to present value times the interest rate times t. This is the interest earned. Interest earned. Okay, so we're going to use this formula here. So what is given and what we're looking for? We're looking for how long, right? So how long means time. So the interest accrued is 125, right? 125. The present value was 10,000. The interest rate was 2.5%, which is 0.025. So all we do is plug into the formula, right? So if we multiply 10,000 times 0.025 will give us 250. Then we divide by both sides by 250. It's going to give us 0.5. So it's going to take us like half a year, or 0.5 years, which is half a year. Okay. Hey guys, well that's it for simple interest. I gave like 3 different examples, and I believe that there'll be plenty for you guys to be able to work some of the problems from the homework for 5.1. Now compound interest is almost the same thing, but here guys, you're going to be investing money. Okay. For example, future value stands for the future of maturity value. The PV stands for principal or present value. The R stands for the interest rate. You have to convert it to decimal, right? So you drop the symbol, the percent symbol, and you move it 2 places to the left. M, this is what's different here, guys. M means number of compounding periods per year. The T means number of years. Hey guys, these 2 formulas are the same formulas. The only difference that the formula on the right, which is future value equals to present value 1 plus I to the nth power, the I stands for R divided by M. So in other words, I'm substituting the I for R divided by M. That's why I have R divided by M. And the N is substituted for N times T. In my opinion, it's easier to use this formula here, right? Because it'll be easier in the calculator. Okay, now, I want to use this formula on the, I mean, here, guys, the keyword was compound, right? So for compound keywords, these are the words, and this is the value for the M. Yearly or annually stands for 1, means it's compounded once a year. Bi-yearly or semi-annually stands for 2, M is 2. Quarterly means M is 4. Monthly means M is 12. Weekly means M is 52. And daily, it depends on the book. Some books want you to use 360, but if they don't mention 360, it's going to be 365. And then if it's compounded continuous, it's going to be a different formula. That's a formula for compounded continuous. So we have to know these keywords to put the value for compound. Okay, so these are crucial. Compound interest can be used to invest a certain amount of money without depositing additional money. So for this section, you can invest money, right? You just put like a sum, amount of money in some kind of investment, and you deposit more money, and then you wait for like 5, 10, 15 years and see how much money you have. This formula is to help you to invest some money without depositing any more payments or monthly money into the account. Okay, this is the example, example 4. Say you deposit $1,000 in an account at your bank that pays 6% interest compounded quarterly. How much money will be in your account after 5 years? And how much interest did you earn? So again, we can use the formula. And like I said before, I like to use the one on the right. It's easier to put in the calculator. So there's always 7 things to find. There's the future value, present value, the interest rate, the compounded, the time, the I, which is R divided by M, and the N, which is equal to M times T. So in this case, you deposit right $1,000, so you're looking for how much money will you be in the account after 5 years. So we're looking for the future value, right? Here's what we're looking for: how much money will be in your account after 5 years, which stands for future value. So the present value is 1,000. My interest rate is going to be 6%, which is 0.06. My M, right, compounded, is going to be quarterly. Quarterly stands for 4. The time is 5. So for the I, right, is R divided by M. If it gives you like a definite number, that's what we use. You see, this is like nice and rounded, 0.015. You never round up, guys, because then most of the times it's going to be asking you to round up to a nearest penny. So if you round off here, you're going to get like the wrong answer because you rounded up too early. Okay. And the N is M times T, right? 4 times 5 is 20. So all we do is plug into the calculator, right? It's straightforward. So you're going to put it just like the way it is in your calculator. So you're going to get $1,346 and 8.855007. If you round out your nearest penny, it's going to be $1,346.86. After 5 years, that's how much money will be in the account. So how much money did you earn in interest? So it's going to be the future value minus the present value, right? The future value was what we just got, the $1,346.86 minus the initial principal, which was 1,000. So in 5 years, you earned $346.86. That's extra money that you earned. Okay, let's do another example. Example number 5. Say you deposit $1,000 in an account at your bank that pays 6% interest compounded continuously. So here's a key word here: continuously. So I believe it's the same problem as before, but now it's continuously. So now you don't have an M, right? Because because it's continuously means it's a different formula, which is a future value equals to present value, e to the RT, to the RT power. So my present value is 1,000. Interest rate is 6%. It's going to be 0.06, and my time is 5 years. So we're going to plug everything to the formula, right? So here, guys, when you use the E, the base E, right here, it's always wise to put this in parentheses, because most of the times, if you're not careful and you just put it like this, right, 0.06 times 5, if the calculator doesn't give you the parentheses, right, then it means that you have to put it there, because if not, there's like I mean, there's a way that you can make mistakes here. Why? Because the calculator will follow PEMDAS, which it will do 1,000 first, and then times e to the 0.06, and then that answer you multiply by 5, right? That's if you don't put the parentheses. So it's always safe to put parentheses here, and then you close them. That way it's going to be 1,000 base e to the power of parentheses 0.06 times 5. Okay, so the answer is $1,349, and it's going to be 86 cents again, right? 86 cents. So after 5 years, that's how much money you earned, $1,349.86. And how much interest did you earn? It's going to be 1,349.86 minus the 1,000, which will be $349.86. Okay. There's another example here. Okay, example 6. Let's say that I want to be earning an annual salary of $100,000 when I retire in 15 years. I have been offered a job that guarantees an annual salary increase of 4% per year, and the starting salary is negotiable. So here, guys, what we're doing here, say that let's pretend that I got a new job, okay, but I want to earn $100,000 for the next 15 years. Okay, but the annual salary is negotiable, and say that I want a 4% increase. What salary should I request in order to meet my goal? Okay. So let's put the formula, guys, right? So again, we're going to use the formula on the right, which was I like to use the I instead of the RM, and N instead of the MT. So now, right? So like I said, 17, 1, 2, 3, 4, 5, 6, 7, right? So there's always going to be one unknown. So in this case, right, I want to be earning an annual salary of 100,000. This is the future value, right? I want this in 15 years, right? So we're looking for the present value, because that's how much I want to be earning. So then my R, my interest rate, is 4%, right? So it's 4%, so it's going to be 0.04. My M, right, compounded, let's see here, right, annual is going to be 1. Because annual salary, so M is 1. The time will be 15 years, so it's 15. Now the I is R divided by M, so R 0.04 divided by 1 is 0.04. The N is M times T, right? So 1 times 15 will be 15. So we do is plug it in, right? And again, so here, right? So I'm going to do what's in parentheses first. 1 plus 0.04 to the 50th power is going to give you 1.800943,506. Then I'm going to divide both sides by 1.800943,506. So we get the future value will be $55,526.45. Okay, now again, let's do it the easier way, right? With one throw of the calculator. Will be something in this sense. I'm going to enter what's in parentheses in the calculator. When I do that, I'm going to, once I enter that, I'm going to get 1.800943,506. Then I'm going to hit my inverse key. After I hit my inverse key, I'm going to see this, what you should see. Should see answered. That means times 10 to the negative 1, which means it's going to be the inverse of 1.80943506. Then I enter the 100,000. So this is my answer. You see, guys, we get the same answer. But if you use it this way, there's an easy flow of the calculator. You don't have to stop it. If you use it this way, right, you have to stop it and then put this so put this first and then divide it by 1.80943506. So there you have to stop the calculator, unless you know how to enter the parentheses on the right place. Okay. the formula uses this formula for the book uses this formula, and also MATLAB. But here you have an option. But I prefer, as a student, when I was a student, I used to use this in the calculator by using the inverse. In my opinion, this would be easier. Okay, but it's all up to the student. Now comes 5.3, future value of an ordinary annuity. Okay, if you notice, now you have a different formula from before. And again, the I replaces the R divided by M, and the M replaces the M times T. So here, guys, future value ordinary annuities can be used to accumulate funds for some time in the future. You must set regular deposits during the specific time. So in this case, say that you want to save some money for your kids to go to college, right? Say that you just got married and you plan to have a kid, and you want to have so much money in 18 years. So when he graduates from high school, he has enough money to go to college. This is a type of investment that you can make, right? An investment in this type. But for this type, you have to pay extra payments, say monthly or quarterly or yearly, but extra payments to meet the money that you need to have in those 18 years. And here are the examples that I'm talking about. Let's say you can afford to save $1,000 every month, and you want to set up an annuity to make interest on the account. You want to deposit $1,000 at the end of every month for 20 years. How much money will you have at the end of 20 years? Another example can be, let's say you're planning on sending your just born child to college when he or she turns 18. Since college tuition is constantly on the rise, you want to make sure you have enough money in 18 years for your child to attend college. So this is a type of annuities that you must set up so you can have that money in the future. That's what's called future value ordinary annuities. And example 7. Again, this is I got it from the example that I did earlier. I like to use these kind of examples because these examples are more like what's the word that I'm reaching for? More like in reality that can relate to us. Okay. So again, example 7, you can afford to save $1,000 every month, and you want to set up an annuity to make interest on an account. An investment company offers 3% interest for 20 years if you deposit $1,000 at the end of every month. How much money will you have in 20 years, and how much interest will you earn? Okay, so let's start out by using the formula, right? So we're looking, right? So we're looking for the future value, right? It says here, how much money will you have in 20 years? So we're looking for the future value. The payments are going to be $1,000 every month. The interest rate that you're going to earn is 3%. So it's going to be 0.03. The M, right, compounded, let's see, compounding means every month, so the M is going to be 12, right? Because the payments are every month. The time is 20 years. The I is R divided by M, so 0.03 divided by 12. If you divide that, it's going to give you a nice definite number here. The M will be M times T, so 12 times 20 will give us, I believe, 240. Just plug everything in, right? So here, guys, we start by doing this first here. We do parentheses 1 plus 0.025 plus parentheses to the power of 240, and then minus 1, right? So this is what we get here. We get 0.82075 for 9953. Then we divide that answer by 0.025. 0.0025, we get 328.301991. Then we multiply that by 1,000, so we get $328,301, and it's going to be 0.9981. So it's going to be rounded out to the nearest penny. We're going to get $328,302. So this is how much money you have in 20 years. I think that's enough for your child to attend college in 20 years. But let's see how much money that you actually put in there, and how much money was interest, extra money that you earned. Okay. So this is how to put it in the. But before I do that, this is how you do it in the calculator. Okay. How to use calculator without clearing or stopping. One steady flow until you reach the answer. So right, so you're going to input that in the calculator, -1, right? So like I mentioned earlier, the numerator, you're going to see 0.82075 right? That's what we have here. Then you're going to divide that answer, right? Divide this answer by 0.0025. And then you enter, you're going to get 328.3019981, right? That's what we have here. Then you're going to multiply that, press on the times key, and then you, right, so you can see it on the screen, and then you enter 1,000, right? So then you get the same answer that we did here, guys. I'm showing you this in green, guys, so when you practice, right, every step in green, this is what you see. I don't skip no steps at all, because I truly believe this is easier to put in the calculator. Okay, because this, at times, if you round off too early, you're going to miss because it's always saying to round off to your nearest penny. So you're going to round off wrong. Okay. So again, how much money did you invest? So how many payments were there? We're going to multiply 240 times 1,000, right? Because there were 1,240 payments at 1,000, which will give us 240,000. So how much interest did you earn, or how much extra money did you earn? So we're going to subtract the 240,000, right, from the $328,302, which is $88,302, which is not bad. So that's how much money you earned in interest or extra money. Okay. Now let's do another example here. Okay, now you are planning on sending your just born child to college when she returns to 18. Now you want to have 250,000 in an account for tuition in 18 years. How much money must you deposit at the end of each quarter in an account paying 5% compounded quarterly? So this here, guys, is a little bit different. Here, this is what you want to reach in 18 years. So how much money must you deposit now? Okay, that's how we should translate this problem here. So we're looking for, right, the payments. How much money should we deposit now? That's your future value, 250,000. My interest rate is, where is it at? It's 5%, which is 0.05. Let's see here, my, at the end of each quarter, right, quarter stands for 4, right? This is compounded quarterly, so it's 4. The time is going to be for 18 years. Now the I is going to be R divided by M, so it's going to be 0.05 divided by 4. And it gives us a nice round number. The N is equal to M times T, which is 4 times 18, will give us 72. So let's plug everything in the calculator. You see here, guys, we're looking for the payment. Okay. So again, I'm going to show you how to use the inverse key, okay? Because it will be much easier. So you're first going to input, right? Here, what's here on the numerator. After you do that, you should see 1.445920268 on the screen. Then we're going to press divide, because we're going to divide it by 0.0125, right? So we divide it by 0.0125. When you do that, this is what you should see on your screen. 115.67362215. So all this, right? All this here on the bracket that's the answer after you simplify it or after you evaluate it. Then you're going to press the inverse key, right? Because you want to divide or you want to multiply the reciprocal of what we got on the right times what's on the left, right? So that's why we press on the inverse key. This is what you should see on your screen. Answer to the -1 on the screen, right? Everything in black is what you should see. Now we're going to enter the 250,000. After you enter it, you get 2,161.25334. Rounded off is $2,161.25. So that's how much money you have to deposit every quarter. Okay. Now let's see how much money. This is only extra information, right? Let's see how much money did you actually put into the account. So I'm going to multiply the number of payments, which is 72, times the total on the payments, which was $2,161.25. So we multiply those. So really, guys, what you put in there was only $155,610. So how much came from your pocket? That's how much it came from your pocket. So you actually earned extra money that you earned, right? We subtracted 250,000 minus when it's 155,610 and we get 94,390. So this is how much money you earned in interest, or how much extra money you earned. 94,000, which is good. Okay. Now comes the present value of an ordinary annuity. This is from 5.4. Okay, the present value is almost the same formula, but what's different? And the other one, let's go. Let me go back real quick. Here you have, this is negative here, right? This is negative. From the previous slide, this was my formula, right? So what's different? The 1 is over here at the beginning, so it's going to be 1 minus that, and that's going to be negative. That's the difference between the two formulas. Okay. So again, this is right. So what are the uses for present value of an annuity? This can be done to purchase like an expensive item, such as your vehicle or a house. Those will be probably your most expensive investments. So for those investments, right, you have to use this type of formula, because to purchase something expensive, you have to be qualified from the bank first, so they can loan you the money, and then you're going to be making monthly payments or quarterly payments depending on the annuity. Here's the examples. Say you want to purchase a car. What are your monthly payments, and how much will you end up paying? You want to get an idea on the process of purchasing a house. Key factors of purchasing an expensive item in payments, right, is you must have a job. You must have real good credit or decent credit. The higher your credit score, the lower your interest rate will be. If you have bad credit, there's some companies that will actually, especially if it's a vehicle, they'll probably finance for you, but they're going to finance at a high rate, which means you're going to end up paying a lot more for your car than somebody that has real good credit. Okay. And also, you have to get pre-qualified for a maximum amount of a loan. So, for example, when you're going to buy a house, right, you don't want to start seeing houses first, because what happens if you're looking for real expensive houses and you don't qualify for a loan of that amount? So that's why the best idea is to get pre-qualified to see how much you can afford. And this way, don't go look at houses more than what you qualify for, because if you do that, other houses that you see that you actually qualify, you're not going to like them, because you were seeing houses that were over your budget. Okay, now let's do examples of both of those. Present value of an annuity continues, right? So here we go. Example 9. You buy a new car that costs $26,750. What are your monthly payments if the interest rate is 4.2% and the loan is for 5 years? And how much interest did you pay? Okay, so let's put the formula, guys, here. So you buy a new car, right? So here, guys, we're looking for the monthly payment, right? So we're looking for the payments for PMT. Right, we're looking for the payments. This is how much the car costs. So this is the amount of money that you borrow from the bank, the $26,750. So then the interest rate is 4.2%, right? Which you have to convert it to a decimal, which will be 0.042. Right, what are the monthly payments? So compounded, so the end is 12, because monthly payments. Most of the times with cars and houses, is going to be monthly. So compounded will always be 12. The time here is 5 years. So to find the value for I is going to be R divided by M. So 0.042 divided by 12 will give us something nice and definite. The N is the N times T, which will be 12 times 5, which will give you 60. I will just plug it in the calculator, right? Plug it in the formula. Now here, guys, I'm going to use, again, the inverse key. So I'm going to show you how to use the inverse, how to put in the calculator with a steady flow. So first, you're going to enter what's here on the numerator. Right? After you enter that, you should see something like 0.189118531. Right? So after you do that, you're going to hit the division key, right? The division key. And then you're gonna write, you should see this on the answer divided by, which means this answer, the divided by, and then you're gonna enter the 0.00335. And this is what you should see on your screen, 54.03385.802. Here's where you're gonna hit the inverse key, right? This is what you should see on your screen. Everything in black is what you should see, and in red, it's what you're doing here. Then you're gonna enter the 26,750. So this is what you see, right? So it's gonna be 495.0599675, rounded out to your nearest penny. So it's gonna be $495.06. So that's how much money will be your monthly payments. Okay. So let's see how much money actually came out of your pocket. Even though the car is worth that much, right? With the interest, you're gonna be paying more. So we multiply the 60 payments times the monthly payments. The 60 payments times the monthly payment will give you $29,703.60. So you paid like about $3,000 extra, I believe. Okay, that's how much you paid. So how much money did you pay extra? Or how much interest did you pay? We subtract the total amount, right, which was the 29,703, right, minus the 26,750. So you're gonna get $2,152.60, which is almost $3,000 extra. How can you avoid? How can you avoid paying that much interest? Is that you give extra money, or you give extra to the principal. So every time your payment is due, so instead of paying the $495.06, so you have like say $100 extra every month, just put that into the principal, and this way it'll go straight to the principal, and you will not end up paying the $29,703.60 for your vehicle. It'll be much less. Okay. Now let's do example number 10. Say you want to purchase a house for $325,000 with a 30-year fixed rate at 3.9%. What are the monthly payments and how much interest did you end up paying? Before I do this problem, guys, let me share like a little story how I when I teach these courses on face-to-face. I was trying to connect with my students right from the beginning of the first week of class. And at times it's hard to connect with them, right? But most of them connect with me like teacher and student, which means they can trust me that they can ask any questions pertaining to math, and I'm going to help them. But most of the times there's some students that actually they don't want to connect with the instructor for some reason. They don't feel uncomfortable, right? So, but every time that I get to this section or to this chapter, mostly everybody's on board. Everybody, I'm connected with every student because for some reason, when it comes to money, it opens the students' eyes and they begin to listen. And I give them like real life examples, like buying a car, buying a house, and stuff like that. So this example here, I actually got it from a student, because once I get to know my students, I actually ask him, hey, what you going for? And this particular student was going like I believe for engineering. And she was saying that she's going to be successful. She was real positive, and she was going to make a lot of money. So I asked her, well, what kind of house do you want to buy? She said, I want to buy like a $325,000 house. Okay, so this is the example that we use. I got it from a student. So and in reality, I use this is real life situation, guys. Right? You say this person wants to wants to purchase a house for $325,000. Most of the times, they're 30-year loans or 50 or 20. There's some 20 or there's some 15, but most of the times they're 30-year fixed rate loans. And this is really the interest rate at this moment right now. It's like 2.5 to about 4%. So what are the monthly payments and how much interest do you end up paying? So say the student wants to purchase this house, right, with these certain conditions. Let's see if she can afford the monthly payments. So again, let's get out the info. So we're looking for the payments, correct? So the present value, this is the amount that we're going to borrow from the bank. The interest rate is 3.9%, which would be 0.039, right? And again, most of the time with houses and cars, the M will always be 12 because most of the times it's monthly payments. So M is 12. The time is 30 years. So the value for I is R divided by M, so it's going to be R 0.039 divided by 12, which will give us 0.00325. The M times T will give us 12 times 30 will give us 360. Okay, so let's plug everything in. So now again, I'm going to do the same procedure as before, right? By putting everything in the calculator. So we start off by putting the numerator, the 1 minus parentheses 1 plus 0.00325, close it to the power of negative 360 into the calculator. So this is what we should see. 0.689043691. Then we're going to enter the division key. So this is what you should see on your screen on the calculator. Now we're going to enter the 0.00325. So you should see 212.0134431 on your screen. Now we're going to hit the inverse key, right? The inverse key to multiply the reciprocal of 212.0134431, right, and multiply by 325,000. So this is what you see on your screen. Now we enter the 325,000. So this is what we get. 1,532.921664, rounded out to the nearest penny. So $1,532.92. So those are the monthly payments. Yeah, and I believe those are is not that much. So a person making good money can actually afford a house with the given conditions. Now, how much money did you end up paying? You'd be surprised here, guys. You'd be surprised how much extra money you end up paying. So we're going to multiply the number of payments, which is 360, times the payments per month. Okay? So it's $551,851.20. So we pay over $500,000 for the house. Okay, so that means that you're paying like $250,000 extra dollars or something like that. Okay? So this is how much you paid for the house. So how much interest did you pay, right? We subtract the $551,851.92 minus the money that you borrowed from the bank. So you end up paying like $226,851 extra. How can you avoid that charge? You can avoid that charge by putting extra money into the principal every month. Okay, an example for that is that, for example, my wife, she bought this house where we live at right now about 12 years ago. And it took me 10 years to pay it off. I use this type of formula, and I will always give extra money to the principal every month. And I ended up paying it in 10 years, but the loan was for 30 years. So I ended up paying a lot less, saving a lot of money and interest that I saved. So why do I like to share this example with students? So because this is like true. It happened to someone, and it happened to me. So this is how you can get rid of paying too much interest, is by paying extra money to the principals. Every month, pay extra money. Okay. Hey guys, well that's it for my presentation for this workshop. Hope you enjoyed it. If you want a copy of this original PowerPoint, just send me a text at or send me an email at aisasi@upcc.edu. I mean email, not text. Okay. Let me stop sharing then. Let me turn it off.
Alrighty. Thank you so much to Mr. Isasi for presenting today. Thank you for the audience for coming and being a wonderful audience. We hope you have a wonderful summer semester and know that online tutoring is going to be open and here for you. I would like to invite you guys to next week's events for the 1324 side of the classroom. Let me share the flyer real quick. Alrighty, so next week for the week of Friday, July 30th, for Math 1324, we'll be covering systems of equations. So we hope to see you guys next week. Thank you and have a wonderful day.